All right, welcome back. Today, we are going to tackle a piece of SQL that, let's be honest, trips a lot of people up. The having clause. If you have ever been staring at your screen, totally frustrated trying to filter your grouped data, then you are in the right place. We're going to make this crystal clear. So picture this. You've just written this amazing query. You're using group by, you're summarizing your data, it's looking great, and now you just want to filter those results a little. Maybe you only want to see the groups with a count higher than 10. So you naturally reach for the where clause, you type it in, you hit run, and bam, syntax error. It is a classic stumbling block. And what's happened is you hit the group by roadblock. But here's the thing. It's not your logic that's wrong. It's the tool you're using. The where clause, well, it just wasn't built for that job. But the good news is SQL has another keyword, a specific tool designed for exactly this problem. And that tool, my friends, is the having clause. You see, the where clause filters your data row by individual row before any of the grouping or counting even happens. It has no idea what the final sum or count is going to be. And that's exactly why having was created, to jump in after all those aggregate functions have done their work. So where does having fit in the grand scheme of things? Well, this order of operations is absolutely crucial to understand. A query always starts by grabbing data from a table. Then the where clause filters out individual rows. Only then does group by come in and bundle the remaining rows into those summary groups. And here's the key moment. Having steps in right after the grouping is totally finished to filter those new groups. Now, theory is one thing, but seeing it in action is where it really clicks, right? So let's walk through a nice, simple, practical example to see exactly how this works. Okay, so we're going to be using this standard customers table. Pretty straightforward. You can see we have customers from all over the world. Our goal here is to count up the number of customers in each country, but we only want to see the countries that are our biggest markets. So here's our mission. Find countries with more than 5 customers. We start by telling SQL to group by country. That creates our buckets. But the real magic is this last line, having count customer ID greater than 5. This is basically us telling the database, hey, after you're done counting everybody up, only show me the country groups where that final count is bigger than 5. And boom, look at that. We get this perfectly clean, concise list showing only the countries that met our condition: USA, Germany, and Brazil. Every other country that had 5 or fewer customers, they got filtered out after the counting was done. Now that is the power of the having clause. Okay, that was a great start, but let's be real, real-world databases are almost never that simple. So what happens when the information we need is spread out across more than one table? Let's level this up and see how the same idea works when we have to join tables first. For this next bit, we're going to need data from 2 different tables, orders and employees. What we want to figure out is which of our employees are the most productive by counting up how many orders each of them has handled. So our query is looking for employees who've processed more than 10 orders. We kick things off by joining the 2 tables to link each employee to their orders. Then, just like before, we group by the employee's last name. And finally, the having clause does the heavy lifting, filtering those groups to show us only our top performers, the ones with more than 10 orders. Okay, this is where it all comes together. We know where is for filtering rows, and we know having is for filtering groups. But what if a problem demands that you do both? Is it possible to filter your initial data before you group it and then filter the final groups after? The answer is a resounding yes, and it's incredibly powerful. Let's ask a super specific question. For just the employees Davolio or Fuller, have either of them registered more than 25 orders? Notice what's happening here. It's a 2-stage filter. First, the where clause acts like a bouncer. It only lets rows for Davolio and Fuller in the door. Then, after only those rows are grouped, the having clause comes in and checks if the final order count for either of them is over 25. So let's just hammer this home so it sticks. Where is your first line of defense? It works on individual rows, and it happens before any grouping. Having is your second filter. It works on entire groups, and it happens after the aggregation is done. And the big one, where cannot be used with aggregate functions like count or sum, while having is built specifically for them. So let's lock in the key takeaways. Just remember, where is for rows, having is for groups. The order is everything. Where comes before group by, Having comes after group by. And your new superpower? You can use both of them in the same query to solve some really complex problems. Okay, now it's your turn. Let's put this new knowledge to the test. What is the primary purpose of the SQL having clause? Think about that order of operations and what it's really acting on. Getting this one right unlocks a whole new level of data analysis. Thanks for diving into this with me today.